Hello everyone, so let's continue. So let's proceed to the classification of real numbers. So let's start with the natural numbers, or they're also called counting numbers. So these are the set of all positive integers from 1 to infinity. So you can denote this as, let's say, if we denote it as n, you can say starting from 1 to infinity. So that is 1, 2, 3. So these are your counting numbers. Okay, so we know these natural numbers well enough. Let's proceed to whole numbers. Okay, now the set of whole numbers, so this is the whole numbers is a slightly larger set than the set of natural numbers. So it's defined as the set of whole numbers contain the set of natural numbers and 0. So if we denote the whole numbers as W, big W, then we can say that this is just the set of 0 and then 1, 2, 3, 4, 5, and so on. So the difference between natural numbers and whole numbers is just the presence of 0 in the whole numbers. Okay, let's move on to integers. So this consists of the set of positive whole numbers and negative whole numbers. So we have here. So if we write it in this notation here, list notation, so you can have what letter should we denote this? Integers. Denote integers as Z. Okay, so Z. Oh, nakuha. Denote integers as Z. So equal to, say, negative 3, because this continues to infinity. So 3 and negative 3, negative 2, negative 1, 0, 1, 2, 3, and then we have it right here. So these are our integers. So as you can see, we have 0, and these right here are the whole numbers. The only difference is we now have negative numbers coming here from 0 to negative infinity. So these are the set of integers. Okay, so the next we have the rational numbers. Now the rational numbers that can be written in the form a over b, where a and b are integers and b is not equal to 0. So why is it that b should not be equal to 0? Because if b is 0, then this will be undefined, right? Okay, so examples of, so here in a over b, so a is the numerator and b is the denominator. So examples, so 1 over 2. So in here, 1 is our a and 2 is b. Okay, so and then this is the result, 0.5. Then b here, and a is 1 and b is 3, and then equal to 0.333, which is a non-terminating and repeating decimal. Okay, so for letter C, a is 1 and b is 4, and then we have the resulting decimal, which is, if we perform the division, right, we have 0.25, which is a terminating decimal. We have a finite number of decimal places. And then for the last example, we have a is equal to 7 and b is equal to 66. This is equal to 0.10606. So the 06 block is repeated here. So, okay. So, what can we say about rational numbers? So a rational number can be represented by a decimal, as you can see here, by carrying out the indicated division. Okay, so if we carry out the division, we get the decimal value. Okay, and then a rational number may be represented by a decimal that either terminates or is non-terminating. But with a repetitive block of digits. So for rational numbers, we have here could be represented by decimals that terminate, and it could also be non-terminating, but it should be repeating. Non-terminating and repeating. Now, what if it is non-terminating and non-repeating? So that is an example of an irrational number. So a rational number is it cannot be written as the ratio of two integers. So dili na to sila masulat og a over b, and it is non-terminating and non-repeating. Okay? So what are examples of these numbers? So these are special numbers, no? So example, very famous example is pi. It is the proportionality constant of the circumference of the circle to its diameter. So pi is equal to c over d, and it has the non-terminating and non-repeating value of 3 point blah 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 3.1459265, diba? You have competitions that they memorize pi to 22,000 decimal places. So they have competitions like that because pi is non-repeating. So if pi was repeating, then there would be no competition at all, because there's no need to memorize if it is repeating. Okay, so the second example is the natural base e. It has a value of approximate value 2.7182818. It is also a non-repeating decimal, so this will be explained in module 6. So those are examples of rational numbers. So we'll continue in the next video to show the relationship between these classifications. Okay.